In this presentation, The Girl in the Spotlight, I'd like to tell you about the technical re-examination of the Mauritshuis's most famous painting, Vermeer's Girl with a Pearl Earring. I'm Abby Vandeveer. I'm a paintings conservator, and I'm coordinating this research and examination project on behalf of the Mauritshuis. I'm sorry I can't be present in person today, but if you have any comments or questions about this project, you can send me an email. In this short presentation today, I'll talk about the 1994 treatment, research questions, samples, imaging, and the technical examination, which will take place in February-March 2018. The Girl with a Pearl Earring underwent a conservation treatment in 1994 in the Mauritshuis. And here's a picture during varnish removal. This restoration was done in view of the public behind a glass screen and viewable from above through a window. Here she is on an easel alongside Vermeer's View of Delft. Here is Nicolas Castaras retouching the painting. And as part of the treatment, conservators and researchers carried out a technical examination. Here, looking through the microscope, on the left is Jurgen Waden from the Mauritshuis, and on the right, Karen Groen from the Centraal Laboratorium, which is now the RCE. The research questions that were posed in 1994 are different from the questions we're asking now. Some of them focused on treatment, and there were also some research questions related to painting technique. Did Vermeer first make a sketch? What sort of pigments did he use? And how many paint layers are there? By gathering information during the treatment and examining and analyzing cross-sections, the researchers were able to answer some of these questions. Their findings were published in an essay in the 1998 book, Vermeer Studies. The article describes the conservation history, the technique, and the layer buildup, focusing primarily on the dark background. Major advances in non-invasive technical analysis have been made over the past 20 years. So now we're embarking on a new technical examination project. The Girl with a Pearl Earring will be examined in front of the public at the Mauritshuis between 26 February and 12 March 2018. It will take place under the umbrella of NICAS and with the participation of researchers from several different institutions. Our research questions are different than those that were posed in 1994, and the most important ones are listed here. They can be divided into two categories, imaging and samples. For imaging, what steps were used in the creation of the painting? What can we visualize beneath the surface? How did Vermeer create different optical effects? And what does the painting look like at a microscopic level? For the samples, our questions are, what further information can we obtain from the old samples? What can we find out about the layer structure, deterioration, inorganic and organic components, and the geographic origin of materials? The samples we have access to now were taken in the mid-90s by Karen Groen and her colleagues, and this has laid the groundwork for our understanding of the materials and layer buildup of the girl. As we've re-examined their results and reanalyzed some of the samples, we've found that almost all of them are still correct. But now the techniques are even more sophisticated, so we can look at some aspects more deeply. Hopefully these results will inform some of the findings and breakthroughs we'll make during the imaging study. But for now, I'll describe the progress that's been made so far on the samples. The RCE houses the samples that were taken from the painting in 1994. 20 of them were embedded as cross-sections, and there are 14 vials, some of which contain enough loose material for further analysis. One of our research questions is, what layers can we visualize beneath the surface? Perhaps Vermeer started by applying a sort of dead coloring in varying shades of brown on top of the ground. In this picture, taken during cleaning in 1994, you can see the underlayers in areas where the upper layers have become abraded. In our forthcoming technical examination, I hope we can visualize these aspects using scanning techniques like XRF and XRD. We'd like to find out more about the distribution and visual effect of these underlayers, and whether they vary in color or thickness. Cross-sections from these areas show differences in the underlayers. In the shadows, the underlayer is thick and dark brown. In the lighter areas of her clothing, the underlayer is thinner and much lighter in tone. The sample from the highlight of the clothing was among those that were examined with SEM-EDX at Shell in 1994. But since then, SEM technology has also improved. As part of the new analysis, together with Annelies van Loon, we've examined samples with the SEM-EDX machine at the Ateliergebouw. It's a low vacuum SEM, so we didn't need to coat the samples. And this is important if we want to carry out more analysis on the same exposed surface of the cross-section. Using EDX, we could examine and identify trace elements that weren't detected earlier. Also, phenomena like saponification towards the top of the paint layer was visible in the backscatter images. To summarize the findings we made from light microscopy and SEM-EDX, the painting has a rather simple layer buildup, and often the layers are straight and distinct from each other, with little wet-in-wet blending visible. We saw unpigmented intermediate layers, the light and dark underlayers, possible dead coloring that I mentioned earlier, and found that there were lots of organic lakes mixed into the paint layers, which is apparently typical for Vermeer. Also, ultramarine was incorporated into the yellow clothing, and we saw some saponification in the paint layers. One of our research questions is about the geographic origins of Vermeer's materials. Using lead isotope analysis to determine the source of the lead-white pigment might help to answer it. This image shows different ratios of lead isotopes in mines from different parts of the world. Within Europe, it's also possible to distinguish between specific regions, for instance, Italian versus Dutch Flemish. As part of the NICAS project, Multi-Isotopic Analysis of Early Modern Art, Paolo D'Imporzano and Gareth Davies from the FU have analyzed samples from the paint and ground layer. They also reanalyzed samples from Vermeer's Diana and her nymphs. Their findings are that all of the lead isotope ratios from these Vermeer paintings are clustered together within the Flemish-Dutch area of this graph. In order to identify some organic components in the paint layers, Art Ness from the RCE analyzed several fragments using UHPLC. In this sample from the background, the new analysis confirmed the earlier findings. On top of an underlayer containing bone black, Vermeer applied a mixture of indigo and weld to create a translucent green glaze. In this sample from the dark part of the clothing, we wanted to find out more about the type of red lakes that Vermeer used. UHPLC analysis showed that the red lakes contain carmine made from New World cochineal, that is, American or Mexican cochineal. And a similar red dye was also detected in a sample from the flesh tone. This is relevant to answering our research question about the geographic origin of materials. Apparently, New World cochineal was brought to Spain in large quantities during the colonial period, mostly for dyeing clothing, and it could have been purchased by the Dutch from the Spanish. To accompany these findings, FTIR-ATR analysis is currently being carried out on samples from the clothing at the RCE by Suzanne Coutucci de Groot. Also, Henk van Keulen will do GCMS on some of the fragments to see if we can confirm and perhaps build on the findings from the 1990s. In samples from the background, the ground was found to contain linseed oil, and a sample of the upper layers could also have contained walnut oil. We're also interested in identifying the binding media of some thin intermediate or isolation layers. In some cross-sections, unpigmented fluorescent layers were visible in UV, especially above and below the brown underlayers. We'd like to know if they're oil, varnish, or a separation of the medium. So scientists at Maastricht University are currently analyzing these thin layers using TOF SIMS. The remaining analysis on samples will be carried out at Shell Technology Center, Amsterdam. The samples will be coded for SEM-EDX so that we can do EDX mapping. DTMS will be carried out if necessary, and FIB-TEM to identify the different black pigments in the underlayers. So now I'd like to move from talking about the samples to talking about the imaging part of the research project. Some imaging has been done in the past, like photography, infrared, and this X-ray that was made in 1982. These will be repeated to reflect the current appearance of the painting. Here are weave angle maps that Rick Johnson made from the old X-ray, and they've been incorporated into the new RKD monograph, Counting Vermeer. The average thread count is within the margin that's typical for his canvases, but unfortunately we haven't yet been able to match the canvas up exactly with other works by Vermeer. We also have some high-resolution infrared images made by MadPixel, and these have been overlaid onto high-res normal light images. You can download the Mauritshuis Second Canvas app for your phone or tablet and use it to zoom into the girl to a microscopic level. And this will also be useful to our researchers during the examination process. The new technical examination will take place in the Gouden Zaal of the Mauritshuis over a period of 2 weeks in February and March 2018. Within the room, we'll build a plexiglass enclosure, and the examination will take place inside. Museum visitors will be able to walk around 3 sides of the enclosure, and information will be shown on screens, and there'll also be an educational program. We'll make updates on social media, through a blog and a website, and through a series of talks and presentations. To examine the girl, we'll use scanning techniques like macro X-ray fluorescence, macro X-ray diffraction, and optical coherence tomography. We'll learn more about the layers at and beneath the surface using hyperspectral and multispectral techniques, and find out about the topography, color, and gloss. It's important to realize that this technical examination is just the beginning of our research into the girl with the pearl earring. The real results will come after the examination, when we've had a chance to crunch the numbers and compare the data acquired using all of the different techniques. Data science will be crucial in this phase. In the end, we'll present our results in many forms, including websites, Rob Erdman's curtain viewer, and scientific articles written by the different researchers. These are some of the researchers that are participating in the project. The NICAS lead partners are in white, and the Mauritshuis is also a member of NICAS. I welcome you all to come to the Mauritshuis during the period of technical examination, 26 February to 12 March 2018. In the meantime, if you have any questions or comments, please contact me by email. Thank you for listening.